Welcome students to I Can Solve an Equation with variables on both sides of the equation. So now we're looking at when we have a variable on the left and a variable on the right, and it could be multiple of the same variable on either side. So make sure you take notes, make sure that you pause the video when you need to. We'll do a couple problems here and we'll do a couple problems when we join each other in class. Make sure you pause right here and write down these steps. First of all, if you have the steps, it's going to be a lot easier to go back and check to see if you're doing the right thing. So the steps to follow when solving an equation with a variable on each side of the equal sign. You're still going to start by making a slide. Keep everything equal. Keep everything organized. You're going to distribute if there is distribution. Remember, that's a multiplication process, so that makes sense that it would become before combining like terms, which is an adding process. So make the slide. Combine like make a slide, distribute if necessary, then combine like terms if necessary. Once you have that, then you might have what looks like a two-step equation on either side. Then we want to move all the variables to one side. We're still going to do this by doing the inverse operation. Okay, so if I'm adding 2x on one side and I want to move it to the other side, I'd subtract it. So you still use the inverse. Then you isolate the variable, so that means you're going to move all of the constants over to the other side that you moved, the opposite side of where the variable is. Then you'll solve, and of course check your solution so that you have the reflexive property on either side. Remember, if you have something that's not the reflexive property, you probably did something wrong and you want to start back from the beginning and look for your mistakes. So make sure you pause and get those down before you move on. Here's an example of having a variable on both sides. So if I follow my steps, I'm going to make my train tracks first. Then I look for distribution. I don't see any. Done. I look for like terms on either side. I don't see any. Common mistake is people try to grab this and combine them. No. They're on opposite sides. They're not being combined. So there is no combining like terms. Had there been another W over here, then we would, but not quite yet. So now we're on to the fourth step, get the variables to one side. So I see that all I have over here is a W, so I'm going to move this one. I'm adding 3W, so I undo that by subtracting 3W. 3W minus 3W is 0, so I'm left with 2. Subtract it on this side. 7W minus 3W is 4W. Isolate the variable, get the variable alone. Divide by 4. 4 divided by 4 is 1. 2 divided by 4. A lot of you are going to say 2. No. 2 over 4 is the same as 1/2. So I'm going to check. 3 times 1/2 plus 2 should be 7 times 1/2. Well, I get 3 over 2 plus 2 over 1 is equal to 7 over 2. Change this to 4 over 2, common denominators. Add 7 over 2 is equal to 7 over 2. So my solution works. And here's another one. So I start, make my train tracks. I look for distribution. I don't see any. So I look for like terms on either side. I don't see any on the sides separately. So that means I want to move my variables. You could subtract 5a over here. I like to keep things positive, so I'm going to move 7 to the left side. So it says minus 7a. So I add 7a, undo, and I get 12a plus 2 is equal to 6. Get my variable alone. Isolate the variable. So bring the 2, the constant, over by doing the inverse. So I have 12a is equal to 4. Divide by 12. 12 divided by 12 is 1. 4 divided by 12, it's not 3. 4 goes into both of these, so it's 1/3. I can check. 5 times 1/3 plus 2 is the same as 6 minus 7 times 1/3. These fractions I know are probably scaring a lot of you. Don't worry about it. So I get 5/3, multiply straight across, plus 2 is equal to 6 minus 7/3. Change these two fractions. 2 is the same as 6/3. 6 is the same as 18/3. So I have a common denominator, so I can add my numerators. 11/3 is equal to 11/3. So my solution is correct. These are getting a little uglier than the ones we did before. Here's another one. I know we haven't seen a lot of distribution yet, but we'll get there. These ones have fractions. A lot of you are right now saying, I'm going to get out of this video, pretend I watched it. No, 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 no. Stay with it. You can pause, you can rewind, stick with it. I'm going to teach you a trick. When you see these fractions, no one wants to deal with fractions. The trick that we talked about the other day is to get rid of a fraction, you can multiply by the denominator. Notice here we have denominators of 3 and 6. If I multiply by 3, that's not going to get rid of 6. But if I multiply by 6, it will. So if I multiply this whole thing by 6, I also have to multiply the other side by 6. It's like it's 6 over 1. Now this is like I'm distributing. So here I get 12 over 3 plus 6 over 6q. Notice I just distributed 6 to both things inside. Same thing on the other side. 6 times 5, that's going to be 30. 6 times q plus 6/3. So now these are going to be these are simplifiable. That's a new word. 12 over 3 is the same as 4. 6 over 6 is the same as 1. 30 over 6 is the same as 5. And 6 over 3 is the same as 2. Look at that. This is an equivalent equation to this. I just made it look nicer. So now, no more distribution, no like terms on either side. I'm going to get my variables to one side. Inverse of adding q is subtracting q. Bring my train tracks down further. So I'm left with 4 is equal to 4q plus 2. Bring my 2 over, subtract 2. And I get 2 is equal to 4q. Divide by 4. I get q equals 1/2. If you don't believe me, plug it back in to check. You can use a calculator if you really want. Couple more here. This one just has decimals. You do the same thing. Subtract this over. Notice we have a negative and a positive. Same rules apply. Which do you have more of? More negatives. How many more is 3 and 1 and 3/10 than 1 and 3/10? Total of 2. Divide by your negative 2. C is equal to negative 1.4. Plug in and check. All right, another one with fractions. You could do this two ways. You could do cross products. Or break it up into more steps, which I'm sure sounds fun for none of you. And just do okay. To get rid of the denominator, which we talked about, multiply by it. Do the same thing on this side. So then I get b minus 4 is equal to, well, 6 over 2 would be 3b. So eventually, we'll get to the same place if you watch me solve both of these. Distribute 2b minus 8 equals 6b. Subtract 2b. Negative 8 equals 4b. Divide by 4. negative 2 equals b. See if that works over here. Subtract b. Negative 4 equals 2b. Divide by 2. Negative 2 equals b. Notice I did two different things, but I still got to the same place. Just make sure you understand how those fractions work. We are going to do more that have distribution in class. Let's just do one more. If you can hold out for one more, we'll do more in class to make sure we understand how to do this, and then you'll get your own practice. So, make my train tracks. Distribute. Distribute on the other side. Combine like terms on either side if you need to. I can't. Get my variables to one side. Bring my constants to one side. Divide. And plug it in and check your solution. I do not expect you to be chasing after me and trying to write as fast as you can. I do expect that maybe you try it on your own and then, pause it and try it on your own and then go back, or watch me do it and then go back and try it on your own and see if you can talk yourself through the steps. So, good luck. Make sure you have the steps written down and bring your questions to class.